And with that, we also come to our first session, which will also be about technology trends. And I think we have great experts here today. And I would like you to please come on stage. We do have Chris Hannon here, representing the USPTO. We have Peyton Meyer, she's with Haynes and Boone. Then we have Vishal Sharma, he's with Metanoia. And we have Smee from Qualcomm. And also we do have Kirti, who is with CSIS, and she is virtually here.
Okay, great. So, Tim, you've already done an excellent introduction of the panelists, so I'm so happy to be here with all of you. I was hoping that in this session, following the opening remarks that we had, we can zoom into a little bit of the big picture. We are going to take a step back and revisit why technology standards matter today in the broader geopolitical context, where there's really a race for leadership in critical technologies right now at a global level, right? So before we dive into proposed policy or regulation to address specific perceived problems, which we often tend to do in these kinds of conferences where the world of standards and patents intersect, with this panel of experts, I wanted to take a step back and really talk about what are these standards, why do they matter, what's that geopolitical competition looking like, and what's at stake. So, I think, Tim, you already introduced the panelists, but let me just quickly highlight that we have a nice mix here, right? We have Peyton and Chris, who are, attorneys, and they come from a legal background, strong in intellectual property. Chris from the U.S. Patent Office, and Peyton, you're a practitioner. And then we have Smee, SVP of Engineering and Head of 5G R&D at Qualcomm, who's really deep down technical expertise in engineering, and of course you too, Vishal, with your engineering and broader expertise. So I'm going to ask you questions that kind of just go through a quick lay of the land. Before I do that, let me just turn to each of the panelists and if you have some opening remarks about this sort of big picture framing on why we should care about technology standards today in the geopolitical context. I invite you for very brief opening remarks, 3 minutes, and then we'll launch right into it. Let's do in this order that I have here with Chris.
Great. Thank you, Kirti. To be brief, concise, standards matter, right? So we see this as a focus of the current administration. It's been a focus of previous administrations. And, I'll get into some of that more a bit later on. But at its core, we've seen a lot of developments just in the past months, right? From the critical and emerging technology strategy that was released by the White House on May 4th to the endeavors of my agency, the USPTO, which is a arm of the Department of Commerce. So all in all, standards matter, and the administration is paying attention to this. Previously, the USPTO has actually released some reports on the topic. So we saw in Tim's opening slide some of the patent data. And I think, when we think about standards at the USPTO, obviously working with our economists, we see patent data is a very huge factor and could play into a sort of thinking and policy making in the space. So to have, just rote patent number counts, right? That's useful, but it doesn't tell the whole story, right? So the PTO has always sort of engaged in sort of trying to educate folks, policymakers in Washington especially, about what does that actually mean, right? So if you have, one company with the most patents, does that necessarily mean they are quote unquote leading, some particular technology? And I think if you look at our February 22 report on patenting in 5G space, you can easily see that the contours of that question are pretty complex, right? So you can have, for all the patent attorneys here will know, varying scope of your claims, right? So you can have technologies that are maybe more germane to monetization than others, right? So there's a lot of that goes into it, just to say that just looking at patent data alone is the end of the story. I think you have to go further than that. But all that to say that any sort of policy making that we're doing and thinking about right now is really driven by those sorts of data points, and I think they're imperative and really underscore the need for us in Washington to really think about what we're doing in this standards context and making sure that we're making the right decision calls and whatnot. So I can go into more of that later, but I'll just leave it there for right now.
Peyton, you're next. I see you sitting next to Chris. So,
yes, perfect.
Go ahead.
Yeah, I mean, I completely agree with Chris. You know, quantity versus quality is a good argument. You know, quantity is where you start, and then quality is kind of where you have to go next. I think with the critical technology space, we're going to be seeing more and more standards for these different areas that don't really have any standards. Like as our keynote was speaking on, AI is here and it's coming and it's going to be standardized. I think sooner rather than later. And same thing with like quantum computing, quantum communications. It's coming, and you know, the time is now to start thinking about these questions. And you know, I don't see standards going anywhere. I think standards are pretty well set. It's just what other industries are going to be starting to see, similar to the telecommunications industry, an expansion.
Vishal?
I mean, I guess we have to look at what purpose standards serve. And we talk about high technology, of course, and that is going to pervade all of the different verticals that we can think of. But really the purpose of standards is to enable interoperability while allowing product differentiation and reducing the cost of production, no matter what industry you're talking about, you know, help the ecosystem to develop and evolve and future innovation and opportunity to happen. And that's going to be, you know, across the board, no matter whether you're talking meat and potato industries or whether you're talking high technology like what Kayvon said. And the other thing is, I just want to sort of lay the land is, we talk a lot about, it's very fashionable and very useful, of course, from a political perspective to talk about, you know, US-China battles and so on and so forth. But as I'll share down the line, my perspective is that, as we said, if you're going to develop the ecosystem globally, I mean, while on the surface you can have a lot of battles at the ground level, you need the standards to really work across countries and across borders, and that's what really happens. If you look at oil and gas and other such industries, and whether a washer in your toilet is standardized, well, it's standardized pretty much the same everywhere, and it's going to have to work. And tomorrow that washer at the toilet would be the AI of your 5G network. So, you know, you can fight about it, but it's got to work across China, US, Europe, Australia, whatever. So that's my perspective.
John, over to you.
Yeah, thanks very much. And I think trying to echo some of the other comments, it's really about innovation and scale, right? So if we look at companies like Qualcomm, where we've been really pushing wireless standards from 3G to 4G, 4G to 5G, and now huge amount of research on both 5G advanced and 6G, it's really interesting when we're looking at innovation. And so we look at a great talk, on the role of AI even working its way into cellular standards. So the perspective then is, as we're innovating, when do we need interoperability? When do we need interoperability across a country? When do we need interoperability between countries? And I think that's the power of standards. It's enabling scale based on that interoperability. And so that's the exciting time we're at now, where we're seeing this kind of technology enables faster advances, the same way early in the semiconductor industry, we could design the next process technology node using the computers on the current technology node. And so it became something where we needed technology to help advance technology. And I think we're seeing the same thing with AI. We're seeing the same thing as communication is going beyond humans with cell phones talking to base stations to the reality of connecting vehicles in a smart city infrastructure, connecting much larger numbers of devices, whether it's a smart factory, whether it's a smart school, a hospital, et cetera. And so it's kind of this interesting reality now that standards matter more than ever, because we do have a lot of technology alignment globally in terms of different countries saying, hey, these are the top 10 list. And then the question is, how do we make sure that we can interoperate together for the good of all? So in my view, standards right now are at this really important juncture of enabling this innovation to bring further scale.
Thank you, John, and thanks everybody. Actually, so I'm going to launch in some questions for all of you to facilitate the discussion a little bit better. And let me just, I think you've all articulated why standards matter right now today, but let me just quickly take a step back, because I heard a lot about interoperability, and technology standards are a little bit more than that. So let me start with you, John. Can you please just take a step back and tell us what are technology standards? Why is there more than interoperability there? And just give us, some concrete examples of some critical cutting edge technologies that are standardized, including but also not limited to 5G, 6G, to make it real for us, like what it takes.
Yeah, and I think it's interesting because you can look at even, you're looking at, here we are sitting at UCSD engineering building, right? And you can look at the sort of courses that are offered today, the sort of courses that were offered 20 years ago, or what's going to be offered 10 years from now. And so what's really important to understand in terms of the role of standards, it's also the role of technology evolution. So we look at computing, right? And so people would learn about operating systems and input-output devices. And you noticed what was then standardized back in the day across these layering so that people could specialize. Not everybody had to build everything. So standards fundamentally are about, if we look at these technology, when you start dividing technology into different components, how do those components interact? When is something a de facto standard because of global scale versus when is something, we should have some written down agreement that is the true specification. Right? So there's a standard and there's a specification. So a great example with a washer, you can talk about the size of the particular washer, in whether that's in, and as we know, if anyone's been to the hardware store not too long ago, you have imperial and you have metric. And everyone's like, okay, when is the US going to move wholeheartedly to the metric system? That's a great example of a really long-term standard. You can think of USB, and even for bringing up Kirti's video feed, how many different standards were involved in that, right? So obvious ones about her camera capturing the compression that's going on, that the communication from her laptop to the network, from the network wherever she is across the world, all the way to the United States, all the way to San Diego, all the way into this room, all the way onto this screen. And so you start seeing that this level of different types of standards that need to interact. And I think that's that core point, that there's many, many different technology pieces. And whenever you subdivide things, just like any academic curricular does, you're bringing in different standards.
I just want to emphasize one more point, John, that, this is, of course, interoperability is an important feature. But with these kinds of technology standards, we are always pushing the frontier of technology. Like, new requirements are being generated from the market, from the consumers. And then it's kind of a mechanism of coordinated innovation where different companies are coming together and innovating new techniques and algorithms and scientific frontiers together to solve those market problems, right? It's not, standards are not, well, there are some, but technology standards that we're talking about aren't purely about interoperability, like, driving on the left-hand or the right-hand side of the road, or the two-prong or the three-prong plug, or I think Vishal gave a nice example of toilets and other such, even pencils are standards. But we're really talking about the other end of the spectrum in standards, where it's a lot about, upfront R&D investment and innovation together as a community in the world. So I want to, quickly move to this, jumping from that, some examples.
Kirti, there's one.
That maybe examples of, yeah.
Just one thing I wanted to add. I mean, I don't want it to. You talked about standards which advance technology, and I just thought of an example from 20 years ago. When the internet was really being invented, so to say. There were all these companies, the router switching companies, that came up with the BGP protocol, because there was a need from the industry. You needed to interconnect the growing networks, corporate networks, and you needed virtual private networks to come up. So that was something that was a market demand, that an example which led to the invention essentially of BGP, and then to the invention of virtual private networking technology, which is pretty much used all across the internet and the wireless networks today. And that's partly involved in having her video show up here. And that's from 20 years ago. And if you look at the standards today, I mean, now it's distributed ledger technologies that are again pushing the boundary of both mathematical computation and how are you going to keep security and identification on a ledger. And that's going to be pushing, the evolution of technology and perhaps standardization as well.
Yeah, this is so interesting. So I think Vishal, thank you for that example, because the point I was trying to make is that what's embodied in these technology standards is a lot of upfront R&D that is done by innovators and companies for many years to solve a specific problem, a specific technology problem that's really cutting edge. And to that end, I wanted to actually turn to you to give some examples of these critical technologies that are global in nature. I mean, you really made the point, I think, which is an important one, that these are ultimately technologies that will end up, they are global and they will remain global, but there is an international race for technology leadership, especially between US and China. So let's just, double down on some of these examples of these critical technologies that are global in nature and why. Would you mind sharing your perspective?
Yeah, so I mean, some of the more advanced technologies you can think of is things like, biometrics. I gave the example of, automatic identification, distributed ledger technologies, cloud computing, security technologies, audio video coding. Of course, we've heard about that, in the beginning. IoT, which is going to, as we talk later, maybe will pervade, all of the industries because of the sensors that you need on various things to automate stuff. And 3D printing and scanning kinds of technology. These are all advanced technologies that are, ripe for standardization. But again, I keep talking about meat and potatoes. I mean, if you look at global standards in things that matter, there's healthcare, education, and agriculture, where there also actually exist a lot of standards. I mean, in healthcare, there are standards for clinical research, for healthcare organization management, like how you're going to manage the information in a healthcare organization. That's for non-clinical practice. And I just wanted to share an example. I just read it up, as preparing for the panel. There's a health standards organization, Canada, that was started in 2017. That's actually including patients as part of the standardization process of what it'll take to do medical, standardization and how their information is going to be treated, what treatments they're going to be given, and so on. And that's a first. That's never happened before. But in addition to that, there's medical device standards, for how you're going to do biocompatibility, how you're going to do medical device software security, or management of the medical device. There's also standards for the software and cybersecurity of the information that's now traveling on those medical devices. If you look at agriculture, there are actually standards for the environmental safety and food safety of agricultural products. There are standards for the occupational and health safety of people who work in the industry, and even something like unmanned aircraft, because you need that for surveying agricultural land and crop production and so on. And there's even standards for actual products. I mean, there's standards for how much contamination you can have in wheat. That actually is done. All of these are ISO standards, and there's a whole bunch of numbers I can rattle off, which control all this. And believe it or not, there's even standards for tractors and what equipment you can put on a tractor. And why is that relevant? Well, because if you're going to manufacture equipment in one country and you're going to use that on a farm in France or Australia or the US, well, you need to have some standards that are going to dictate, how your equipment is going to function. And believe it or not, there's standards for education as well, where, people are talking now in the ISO about how we're going to manage education and what kind of frameworks do you need to deliver education. So there are all these areas, which are critical.
So thanks, Vishal. And actually, you really pushed me to draw a very important distinction that I want to, for the sake of this panel discussion and for the rest of the conference as well, which is there's this range of spectrum of the kinds of standards that you just talked about. And in that range, I would say there's an extreme left and an extreme right. Maybe on the extreme left, it's purely about interoperability, right? Like tractors or the thickness of pencils and things like that. And on the extreme right, there are some cutting edge critical technologies. You mentioned some, security, AI, quantum compute, 5G, 6G. These are sort of on the other end of the spectrum, right? Like less about interoperability. Yes, there is, that's an important and an underlying feature, but it's really more about innovation in the cutting edge. So I'm really talking about the other end of the spectrum, the right-hand side, where it's less about interoperability, more about really cutting edge technologies where long-term R&D has led to these breakthroughs and is continuing to lead. And there we see this, geopolitical race for leadership in these standards. And there's a very strong national security dimension that intersects with those kinds of standards. I mean, you can understand when you talk about security or 6G or quantum or AI, that raises alarm bells in Washington. And indeed, now different parts of the world have recognized that we need to have a strategy at a national level to be able to lead in these kinds of critical, what I will call technology standards, not the interoperability types, but the technology standards. So we know that China has a China 2035 standards ban. We know that Europe has a EU standardization strategy. The US came up with a standards strategy document not so long ago, actually last month. And the Biden administration is focused on US leadership in standards development, the integrity of the international standards ecosystem. So I'll turn to you, Chris, to give us an up-to-date on some of the recent US government initiatives to embrace the importance of standards and how do we maintain it.
Sure. Thanks, Kirti, for the question. As you mentioned, as I mentioned at the top of my remarks, is that yes, on May 4th, the Biden administration released their U.S. National Standard Strategy for Critical and Emerging Technologies. So as Kirti mentioned, really that's focused on those sort of cutting edge technologies, those critical and emerging technologies, like we've said, quantum, AI, bio, communications technologies, all the usual suspects are there. So that's sort of the focus of this particular U.S. strategy. And what it does is it lays out 4 objectives within it. So the first, and probably one of the most important ones, right, is investment. So how do we actually fund and maintain this pipeline of resources for R&D development so that U.S. firms are able to actually maintain that pipeline of technological innovation? The second goes to participation, right? Because that's key. If people aren't showing up and they're not going to the standards bodies, that's an issue, right? So we have to make sure we have U.S. firm representation at those standards bodies. The third prong of the objective list there in the standard strategy refers to workforce. So as standards professionals today, they age out of the workforce. There is a need to make sure that we're educating and making sure that the next generation of standards professionals is actually being maintained so that, going to even, research, university students and mid-career folk, how do we make sure that those folks are well trained into the ecosystem of standards and the processes that are involved there. So that's the third objective of the U.S. Critical and Emerging Technology Standard Strategy. And the fourth goes to integrity and inclusivity. And so this is kind of what Kirti was touching on, and what we mentioned is this dynamic where we see some foreign member countries that participate in these bodies, maybe they want to sort of bend the rules to an extent, or maybe sort of make it less about a voluntary consensus standard basis for the work that's done in those bodies. And how do we sort of address that? So I'm from the USPTO, the U.S. Patent and Trademark Office. So one of the things that's mentioned there in the standard strategy document is actually the participation prong. As many of you may be well aware, there's been a series of remedies statements for SEP, FRAND licensing that the U.S. government has put out between the USPTO and the DOJ Antitrust Division initially, but that was 2013. There was a subsequent revision to that statement in 2019, and then most recently in 2022, the current leadership decided to sort of pull the plug on that vacillating policy statement game. And the idea there is, and I would advocate to all of you, that if you read any of those documents, they can be read in comport with one another. Effectively, at the core of them, they say, let the facts of a case dictate the outcome, whatever justice may require. And so this ultimate withdrawal of this SCP remedy statement was viewed under that second objective of participation, because we want to make sure, as the U.S. government, that we are actually removing any barriers. So to the extent that you could perceive any interpretation of those statements to mean one thing or another thing, that's bad, right? So we don't want to have the ability of some foreign government to look at something the U.S. puts out and interpret it in a way that was not the intention, right? So by removing that, it effectively removes a barrier that we saw as one mechanism to incentivize participation for new entrants maybe into a standards body. So that's one thing that the PTO has done. Another thing that the PTO is doing in relation to the implementation of this standard strategy revolves around a partnership that we've done with the World Intellectual Property Organization, WIPO, where we've actually set out to, this maybe goes in a little bit to the workforce objective of the strategy too, where we want to make sure that if there are startup companies, and I think Kayvon from Afino was a great example. Esmail's here, and he actually helped us with a recent webinar on this. But basically, how do you get the word out to small and medium-sized enterprises that are maybe wanting to get their feet wet in standards for the first time? How do you give them the resources and the education, the training to make sure that they're actually going to be able to, figure out how to navigate a FRAND licensing dispute, for example? How do you do that, right? So we've partnered USPTO and WIPO to sort of bring some of that education through a series of webinars that we're continuing. We've done 2 now, looking to do the 3rd one next. So just things like that we're trying to engage on to really make sure that we have a way to implement the strategy. And I know my colleague from NIST is here, so NIST is obviously doing the lion's share of this work, so we're very grateful to have their guidance and support as we start to implement some of the strategy document. But definitely stay tuned, because there's going to be a lot more work ahead of us.
Yeah, so thanks for calling out NIST. We'll hear from Gordon. Are you in the room? Okay.
Yes, he's here.
Sorry, I can't see the room right now, but we'll hear more later. Now, listen, I want to ask a little bit more of a provocative question following your nice presentation of this USG document that just came out, Chris. So is this enough? So let me start with you, Peyton. Let's just take a step back. What does the US need to do to maintain its lead in technology standards? And let me just frame this in a way that this answer is not a given, right? It's not necessary. It's not a given that the US is just going to maintain its leadership in standards with or without this document. And the reason is, there's massive investment flowing into technology standards, critical ones, the ones that we are talking about, critical edge, cutting edge tech, from China and from elsewhere. And there's a real competition for tech leadership in these areas. It's never actually been more competitive. John, maybe you can talk a little bit more about that, but let's start with Peyton. Do we have the right policies in place with this document and otherwise? What do you think?
Yeah, I think I'm hopeful. I think it's not a guarantee. In the United States, I see 2 big hurdles in holding a technological lead, especially with these critical technologies. So if you're not familiar, like the government has enumerated the list of what they see as critical technologies, and this includes AI, quantum computing, supersonics, among others. I'll talk mostly about quantum computing because that's in quantum technologies, or some people call it quantum information science, because that's what I'm most familiar with. But the first being the educated workforce problem, and the second being the dichotomy in the United States between a private industry and government interest. So the first issue with the United States is having a workforce, like Chris was saying, that is ready to take on and innovate. And so, quantum computing, quantum sensing, quantum communications, all of these things are relatively new ideas. AI is expanding into all sorts of different areas. So we need to have, not only the workforce who is innovating, but a workforce who's capable of using these innovations. And looking at quantum computing, a recent, actually the National Quantum Initiative Act, if you're familiar with that, was passed in 2018. It's up for renewal in 2023. And they released a report this month. And they had statistics saying that over half of graduates in the United States for quantum information science are non-U.S. citizens within the U.S. So that's kind of the big hurdle right now in the United States is having, letting people know that these are career options, and getting a career built in the United States for citizens, knowing that this is an option. And then also, I think there should be some regulations and policies. This is what I think is missing, to incentivize people who come to the United States to get a PhD to stay in the United States. And that could be, helping with the process to become a permanent resident or a U.S. citizen, or speeding up the process, for people in the critical technology space. And, that kind of bleeds into my next point, which is, the dichotomy between private industry and government interest. It's, like you mentioned, it's pretty clear that there's some national security concerns, right? Like you think of quantum computing, has wonderful potential to do wonderful things, do computational chemistry that we can't currently do. I mean, that leads to drugs and great medicines, but then also, it could crack any encryption that we currently have. So that's a bit concerning. And so with that, a lot of these things, a lot of the critical tech falls under export control laws. Well, software can be a deemed export under the EAR, so that creates issues if the people that you're working with are not permanent residents or not U.S. citizens. So that's difficult for private companies. That's expensive. It's time consuming. They have to have HR, IT policies in place. And so if we can help have the workforce, that's going to be great. We don't see the same issues. China, Europe has the workforce in place. So it's a big issue in the United States. Similarly, the government has national security concerns. Well, private companies need money. And, the way to get money is to sell a product. And if you're limited to where you can sell your product, you're going to be potentially left behind. So there has to be regulations and policies in place with export control laws to balance these national security concerns, but also be cognizant that in order to be successful, in order to be leading in a technology, you need to be working with others and you need to be selling your product. So I think how it shakes out will largely be based on those 2 points.
Yeah, that's really, really good points. Thank you for articulating that. I do worry about that because there's sort of this narrative that's taking hold that maybe we should have a bifurcated world, right? Where there can be different standards, like the US has its own standards, China has its own standards for certain kinds of technologies, but then that leads to this issue that we've basically shrunk the size of the market for everybody, and then there will be less investment flowing in. Let me quickly turn to John before I move on to the next question. There were some elements in this question, John, I wanted you to weigh on, and anybody else who would like to. But I'll start with you. So, how do you see this technological competition in geographic terms? Do you see it has intensified over the last several years in the standards that you've been working on?
I would say it absolutely has. If we look at critical technologies, giving the example of the 5G research that's happening right now, the standardization that's ongoing, we've seen a recognition that the investment that we're seeing in other countries, in particular in China, is much higher than it was 10 years ago. And I think what's interesting is it also speaks to the other interrelated comment on scale and investment and monetization, that obviously publicly traded companies have many different stakeholders, including their shareholders. And when we're looking at kind of growing addressable market, we need to be able to play in a fully open market environment with international sales and getting that global scale. And at the same time, we've seen, while there's been a lot of consolidation in some industries in the United States, the exact opposite trend's been happening where more and more companies are popping up. And even if you look at how many car companies there are in China right now as a great example, there's many, many different vendors out there. And that's a good thing in the sense of more participants, more players. But when it comes back to the investment that's required to be at the cutting edge of some of these leading technologies like cellular communication standards and bringing AI into 5G, that's not something you do with 3 or 4 people sitting around a conference room. You actually need a significantly larger team that's running advanced simulation, that is able to afford powerful computer clusters, that's able to do sophisticated technology. And that's when it comes back to, well, what investment is feasible as you're creating this innovation? And what's interesting is there's been a lot of dialogue also, I think this morning already, on there's some innovation that does not make its way into standards and some does. And so it's very subtle as to what is standards essential intellectual property and what is implementation intellectual property. And a great example, we have very, very sophisticated cellular networks. They're only going to get more sophisticated. And at the same time, we have incredibly sophisticated cellular products that are also only going to get more sophisticated. And I think it's a huge area existentially in and of itself is what's happening on the network side, what's happening on the device side, what's happening within the air interface. To this example of the 6G AI native air interface compared to what's happening right now on some of this, channel state feedback in Release 18 for AI or beam management or mobility, and how that makes its way into the 5G advanced standards. So the point I'm trying to make is that it is a huge amount of investment required to participate at the upper echelons of this field globally. And we've seen that in the United States, relative to other countries, the question is, are we able to continue to invest at a scale that's necessary to be competing effectively in these areas? And I think that's the part where we can see the consumer scale industries that naturally attain a significant market capitalization, that attain a huge kind of customer base. And then you have some of the harder technology where it doesn't necessarily immediately have huge scale, but it's still very challenging. It takes very sophisticated scientists and engineers to be able to participate in that. And so that is absolutely the challenge of maintaining that technology.
No, go ahead. I mean, I wanted to ask a question. So what would it take? What does it take to continue that kind of investment?
I mean, it does, certainly it's something that it takes a commitment to recognizing that it's long-term. And I think the other thing is this was kind of alluded to as well, the kind of a global alignment of NRE, right? So when you look at big steps, there's a reason the Gs happen every 10 years, whereas there's incremental releases around 5 or 6 of them between Gs. And that's why we're talking about release 18 for 5G right now for AI, whereas the first 5G phones that were out there were based on release 15, and the phone in my pocket is a release 16 phone. So there's examples where the standard is making certain steps, but there's a big step that occurs, and that big step is something that happens at an international level of an NRE alignment between public-private partnerships. What is the government funding? Amazing universities like UCSD, their advanced research happening in academics. How does that relate to global alignment of working on similar topics at similar times, recognizing that this technology, some fraction out of it is going to make it into standards. It's going to make it into sophisticated designs. And I think there's that point of that alignment and that investment and that recognition that not everything's about the stock market in terms of what defines a powerful investment. And so that's where we've recognized, whether it's immigration, whether it's export control, whether it's the aspects of having a workforce that can truly compete at the highest levels. That's the part where there is an urgency to make sure we address that and address it early enough that we're prepared for this kind of international reality of significant technology advancement in many different growing intersecting fields. So that finishes my answer.
So let me also add intellectual property because we are at the heels of the IPBC. IP is another pillar among the ones that you mentioned, John, that incentivizes this long-term investment, especially in the United States or in most parts of the world where we don't have the subsidies from the government, we don't have the public sector funding to be able to pull the weight for the kind of long-term investments that you're talking about. But I'd like to ask this question from Vishal and from Peyton. Peyton, you already answered, but and others in the audience later when we go into the Q&A, what would be the ask of the industry from the government for ensuring that these kinds of investments continue to flow to maintain technology leadership? Vishal, do you have anything to add here?
Kirti, I mean, the only thing, I think others have already emphasized that, but I mean, one of the big asks which Chris mentioned and Peyton as well is you need a trained workforce and trained in the technologies, not both in terms of how they're going to innovate and in terms of how they're going to use it, which basically means that you have to go back to making sure that your educational, institutes and educational pillars, whether it's UCSD or Berkeley, UCLA, MIT, whatever, and many, many others. I mean, these are just the names we keep talking about, but there's a whole slew of US institutions that are producing these talented individuals. I mean, that whether they remain at the leading edge, and one way the government can do that, and it has been doing it, but maybe it has to be more conscious now, is through the ARPA type funding. There's all these government funds that have have had a history of initiating all of the technologies that we are all using today. They all came from initially huge government investment, and now with the critical technologies that have been identified, one has to make sure that kind of funding continues. And that's where the public-private partnership can happen. The government funding is providing the educational, foundations for the workforce to emerge with the knowledge of the technologies and the ability to use them. And that's what comes to mind.
Yeah, thank you. Thank you for that. And, I'll also just like to transition this conversation into this narrative that we've been talking about, right? Like this geopolitical race for technology competition. There is a narrative in Washington that maybe we should bifurcate, like decoupling. Peyton, you mentioned export controls. We've discussed that a little bit. But there's this other idea, and especially in the world of standards, that, as John was saying, this competition has been intensifying in some of these critical cutting-edge technologies. Why don't we consider living in a world where the US has its own standards and China has its own standards and maybe Europe has its own, or maybe there are some, reimagining globalization, certain factions of regions have their own standards and others have their own. In other words, a form of deglobalization. I want to hear from you guys about what that means in terms of its cost. What are the benefits of global standards, and what would be the cost if we do indeed start living in this kind of what I call a bifurcated world, and who would that cost be high for? Who do we want to start with? Peyton, why don't we start with you?
Sure. So I see it probably a little differently, but I foresee that it's very possible that China and versus everyone else almost could be bifurcated in the standards of like quantum computing. And the reason, and that's very specific, but I think there is an odd occurrence where everyone is agreeing in our government on both sides of the aisle that critical technologies are important and need to be protected. And because there's so much bilateral support, I think there is a possibility that it's, the U.S. Has done a ton already to partner with our allies in this field, but they've also done a lot already to try to prevent companies from, selling to certain companies in China. And I think it's only going to be to see more of that. Honestly, I know that's not necessarily what people want to hear, but it's just something that I foresee in that space. Similarly, I see it in the AI space. China doesn't seem to want to follow the same AI protocols as everyone else. I know the G7, right, met last month and discussed standardization and meeting to discuss what is next steps for AI. And so I see a lot of globalization, but I don't think that it's necessarily everyone in the room at all times. I think that, in an ideal world, that's what would happen, because the most people you have in a room, the better the technology is going to be. But I do foresee a little bit of that bifurcation continuing.
And I can just add on too. I think, from the IP perspective, right? So Kirti made the point of it's so critical to these emerging technologies that we have patent protection and other intellectual property protections in place so that folks can recoup their investments. And so when we see sort of a fracture in the international policies that govern the enforcement of any IP rights, that's a real issue, because we see this, we've seen it in history, right? You can go back and you look at examples of regulators in one jurisdiction trying to sort of champion their own homegrown technology at the detriment of someone else, and ultimately that brute force political goal doesn't really always work out as was set out to sort of have the end effect. I'm thinking, you can go back to the 50s and 60s with color television, right? PAL, NTSC in the US, and France had their CCAM color television, and they tried to go to the French colonies and say, here's the technology, implement this, everyone needs to use this. That didn't really work out, right? I mean, PAL, NTSC won out, and in the end, right, we're all moving to DVB anyways. So just to have that will is not enough, right? We need to make sure that we have policies in place and work with allies, and to the extent that there are outliers, sort of bring them to the table to show them that having that global market is beneficial, right? And end consumers are really, I think, the ultimate benefactors of that, right? Because you get the best technologies, and that's what, to me, I think at its core, that's what standards should be about, is bringing the best technologies, agnostic of where it came from. If it's the best technology, that should be what we all have carrying around with us, utilizing every day in our lives. So I think we need to really pay attention to that and make sure that any of these sort of domestic policies that sort of try to champion one nation over another, it's just, from history we can see that's not maybe the best route, and we need to like be thoughtful of that and try to forge a way forward so that we can actually maximize societal benefit through standards.
And I think it kind of speaks to when is from a scale standpoint and a net benefit, right? You ask who's going to lose the most, and you could argue that when we look at the distribution of how technology is already, adoption of very high end. We recently saw last week a $3,500 headset, right? So that's definitely not something for the masses that's going to make sense for someone who's having problems, buying their child a computer to be able to do their homework, which is essentially a prerequisite now. So you have a reality that the globalization does enable many more participants, and it does enable, there's fields where it's not zero sum. That is, we all can benefit. So I know Vishal's gotten some good examples on agriculture or healthcare, things where it's common good if people are able to live more successful, healthier lives, where they have better access to education. So there's many examples where standards enable all of us to benefit from this technology advancements in a more uniform way. And at the same time, yes, there's always going to be product differentiation and ability to kind of define who your target customer is, and everyone can have a different approach to that. But at the same time, then when we start saying, hey, bifurcation can accomplish certain short-term goals, the reality is there's so many interrelated technologies on different timelines that I definitely agree with Chris that history has shown us that doesn't typically work very well, because there's going to be a lot of unintended consequences. It's not linearly predictable that, oh, okay, so let's have two standards for this and it's going to be clean, because reality, things change in unexpected directions. Bringing large language models into computing can change a lot of different fields almost overnight. And so there's a great example where you're not going to be able to really predict accurately some of the benefits of what some might advocate as bifurcation. And so in my view, it's much more important to try to maintain, whenever possible, this global interoperability. And I think it also speaks to what is the fundamental goal of technology. And when we look at critical technologies, we can look at what does that mean for GDP. We can look at what does it mean for citizens, what does it mean for education, what does it mean for healthcare, and what does it mean when there's conflict between nations. And I think obviously there's examples of that occurring right now, where how does technology enable international cooperation to do certain things more effectively. And so in my view, the risk of bifurcation is always there, and the temptation to say, hey, that's a great solution. In my view, you're much better off saying, hey, let's make sure the international standards are happening in a way that's fair and that makes sense technically and that enables that overall advancement. And it kind of underscores this is an area of international cooperation that's now more important than it was before, because of the more disruptive effects of some of these technologies that are evolving as we speak.
Kirti, I just wanted to add one perspective here. I mean, the bifurcation that we've been talking about and that Peyton was talking about, I mean, I just am bringing another perspective. I mean, it might be a good thing in the end in the following manner, right? I mean, you can bifurcate, and now you're in a technology race, so you're innovating, and maybe you're innovating in different pockets, maybe in China, India, US, wherever. But the ultimate arbiter of who adopts that innovation, luckily, is the end consumer, and the end consumer is a globalist today. I mean, so what might end up happening is that you have this technology bifurcation, you develop these high-end technologies, the critical technologies we've talked about, but ultimately it's the end consumer who's going to consume them at some level. And if the consumer decides that certain things are better than others, then I think it'll be a whole lot easier in the world we are moving towards for the consumer to be able to control that. Because you can put all kinds of restrictions, but at the end of the day, the useful technology is going to make it into the hands of the consumer no matter what. And where the consumer is going to start deciding, and at that point, the best technology
Let me
may
push
win.
back a little bit on that, right, Vishal? I mean, there are governments that can mandate standards, right? I mean, we have had government mandated standards in the past. Well, 2G GSM was a government mandated standard. So I can envision a scenario where, let's say China or India, there's a standard developed and the government decides that that's what's going to be enforced and implementable in the entire country. So the manufacturers of those kinds of products get a leg up. So in that kind of a world, I would imagine, I think John and Peyton made that point that the scale economy effect actually hurts primarily the US companies, where, you're just limiting the size of the market in a very real way for those technologies.
Yeah, so it's possible that in some technologies you may have that, but there could be others where you may not. So again, that's going to be decided over time and the significance of the technologies in question. I mean, there may be some very high technology.
Look, I mean, I sit at CSIS where we talk about national security all day long, and when we talk about artificial intelligence and quantum compute, one of the things that's front and center in the discussion is that with these critical technologies, quite frankly, the economics of warfare changes. It's a much more egalitarian world where there's a level playing field because of technology, right? So there's a real desire from just a statecraft or national security perspective to be able to lead in some of these critical technologies and ensure that those are the ones that are implemented in your country, in your region, in the sort of the area of control, if you will. So if that is a world we start living in and we, sort of diverge from a world of global standards, we may find ourselves in a world where we, commercially suitable, the best technologies may not be the ones that have the most access to the market. And that would not be an ideal world in which, you and I may want to live, but it can happen. And I would call it a real threat to benefits of a global standard system. Any comments on that, or did I freeze?
No.
With that.
Well, I can say I'm no national security expert by any means, but no, I think that's right. I think Peyton sort of made this point a little bit, is that when we think about standards around AI, and if you have differing geopolitical goals with your AI systems, facial recognition, to detect and sort of surveil, right? We wouldn't necessarily want to, step to that level, right? Just for the sake of having an international standard, I don't think. But I think that's something that we have to bring our democratic values to those types of AI-based standards, so that we do end up with something that we want is beneficial for our society. But to the extent that if that necessitates some sort of bifurcation, then maybe that's an example of when that would be productive. Because I really think that we should never sort of sell our value short just for the sake of internationalization or globalization.
So this is where, to me, this is where the tension lies, right? The tension lies between there are real benefits to a global standards regime. And I want to talk a little bit about that. Maybe we give you the floor on that, Vishal, because you're such an advocate of that. But then there is also sort of these national security considerations on the cutting edge critical technology side. However, if we go too far too fast, let's say we live, what you just said, Chris, that we have these other considerations and, it may not necessarily make sense to have global standards. We still have a mega cost to pay, and that mega cost to pay is loss of access to a large market, which means that the investment that flows into these technologies naturally from, companies like, Qualcomm or others in the room reduce, ultimately hurting US leadership in those technologies anyway. So to me, that's the tension we are playing with. On the one hand, there is a lot of benefit to global standards, but on the other hand, there is a potential need and a desire growing in different parts of the world to create some kind of a bifurcation, and how do we deal with that? So to unlock that, maybe Vishal, we start with you. Like, just, you talked so much about the big picture and healthcare and education and agriculture. Just what are the benefits of these technologies in general because of the standards being global in nature? Like, let's just hone in on the global point.
I mean, that is something I alluded to earlier, Kirti, which is, I mean, these are all areas where John said that as well, where you can have, it's not a zero-sum game. It's something that benefits the entire, population, and there is not much advantage in having a vested interest in having your own healthcare standards where relative to maybe, standards in quantum computing that Peyton was talking about. Although you could apply quantum computing to healthcare, so then it becomes a little dicey. But if we look at sort of more vanilla healthcare or vanilla agriculture and so forth, there's definitely value in having, global standards where you are not so much, so protective of what you need to do. But I'm thinking as I'm listening to the others is that there are clearly these some very advanced technologies. But my point there, Kirti, is that when you look at the advanced technologies, and John mentioned this earlier in the discussion, is who's the consumer of that? Like, there are only very few people who can buy $3,500 headsets. Similarly, there may be very few industries and very few things where you can use these very advanced technologies. And where is the locus and the center of gravity of the users of those technologies? It may not be in the rest of the world. It may concentrate very heavily in the developed parts of the world where there is the ability to consume those technologies. So while it's true that you may have a race and a bifurcation, but the ability to actually, let's keep aside a moment where you can make massive government investments, and that's certainly possible. But by and large, if you're not just focused on that, then the locus is still going to be a large part of the developed world, which is going to use those advanced technologies. So even if you have a bifurcation, the consumers of the technology are going to be in a part of the world where the technologies are being, the bifurcated technologies are being developed, Kirti. So that's another thing to keep in mind.
John and others, do you have a view on this?
I think it will quickly tie back to export control and because you can create an artificial market, right? And so there's some famous examples even in cellular where, a country would say, hey, we're going to have our own version of a standard, and then you don't have the scale. But you can force all your local vendors to do it. You can force your local operators to deploy it. You can force and the consumers in that sense don't have the choice because they're not global consumers. They can't go, buy a cell phone in Europe and then bring it back to this particular country. And so there's examples where if we start having, getting out in the sandbox and drawing little quadrants and doing a Venn diagram, saying, okay, this standard is only for this country, this standard is for that country, this standard is for this country. I think relatively quickly there ends up being many losers. And then you can say, well, who's the winner then? And then the question is, what does win mean? Does win mean that you were able to have private companies that had higher profits for some period of time? Does it win mean that your citizens were somehow had a higher GDP than they would have otherwise compared to another country? And that's my perspective, that we're going to have more losers than winners because the definition of winning is not entirely clear in this construct. Because what you really did, you brought in some artificial separation of investment in innovation and return. And that's the point, is that, there's still 3G phones out there, right? There's a reality of these things last a very long time. And in particular, when we're looking at, how technology gets used, there's initial use cases, there's follow-on use cases, there's combination use cases, and these end up taking a life of their own. And so my concern a little bit when we start saying, hey, bifurcation could make sense for some but not for others, is it immediately brings in a lot of advanced technology predictions as to what's going to be combined in the future. I do agree there's obviously national security concerns when it comes to cybersecurity. And so does it make sense that two nations that are generally opposed on certain international parts say, hey, we want to have our own version of computing standards, well, then you start to say, okay, well, let's look at computing for government use. Let's look at computing for civilian use. Let's look at computing for advanced cancer research. And then you say, well, it's kind of the same computer that can be obviously programmed in different ways. Does it really make sense? Because what's truly the definition of quantum now versus 10 years from now? And so I think that's the hard part, where there, in my view, there's certain things that are clear, that you need to have investment in technology, you need to have the workforce, you need to have the education, and then you also need to have the benefit spread across a larger percentage of your society for those advanced technologies. So if we look at those four vectors, I think what's positive is that, as Chris and others have mentioned, the United States has woken up more to the reality of immigration as a key part of having a technically trained workforce, and how does that dovetail back to STEM technologies and making sure we address earlier in our education system a need for science, technology, engineering, and math, and coding, and those technologies, so that we're not in a situation of always importing. I grew up in Canada, and I've had many different types of visas over my time to eventually have been a graduate student in the United States and an employee in the United States. But it is something where that reality of global citizens and movement of people is core to how technology gets advanced as well. And I think that's the interesting thing, that immigration policy and academic conferences that are always inherently international, that's another huge area of cooperation and exchange of ideas. And so when we look at advanced tech and we look at the standardization of that tech, then just like the academics are inherently going to share material with each other, the same thing should occur in the standardization, because that's where advanced tech is getting mixed in interesting new ways.
Well, I always forget you're from Canada, John. Thanks for the reminder. So what I'm hearing from you is basically like a small pool, high fence approach. So there are certain technologies where, from a national security perspective, it may make sense to bifurcate, but they're really very specific, very few. We should be very, selective about them and have a high fence around those. But really, like when we wield tools like export controls or bifurcation of these standards, we should have like really narrow and specific approach because of such importance of and benefits of the globalized standards. So I guess my question to all of you would be then, what can we do to maintain a global standards regime? I happen to have some strong opinions on this as a former standards engineer and generally like an economist policy person on this. I do think that we need to be very careful about maintaining an open, transparent, consensus-based majority voting process, and really like hold all the standards organizations and nations that participate in them accountable to that like high sort of bar, so that there's no gaming the system. But I would love to hear from all of you. Maybe we start with you, Chris.
Sure. So, as a patent attorney, I think my focus here is really on the IP aspects. And we see, I guess it's only been a couple hours in the conference, but I'll go ahead and bring this up, break the ice on the European regulation proposed for standard essential patents. If anybody's not familiar, this is basically 4 ideas really at its core. They've got this, the concept of having a essentiality check, right? So you'd have an administrative determination, non-binding, about whether or not your patent is essential to the practice of a standard or not. You have from that, they also have a register that they would basically build out a list of all SEPs that are in the European Union. They would have a FRAND determination process. So again, another administrative determination of whether or not your patent is, necessary some rate according to the FRAND terms of whatever standard you're applicable to. And then they also have a ability for aggregate rate setting within that. So I think that's an example of sort of this rogue approach from one jurisdiction that's trying to set rules that has repercussions for the rest of the world if they're going to try to enforce their standards. So in keeping that globalized standard system, I think we have to be very cognizant of what those changes would have and what unintended consequences they could have, right? So if you have all this new administrative burden for anyone that wants to enforce their patents in the EU, what does that then do for other jurisdictions, right? So maybe you don't go to the European Union anymore, right? Because if you're going to be able to license on a global portfolio basis, maybe you go to Colombia as a patent owner and you say, I want to enforce my patents now in Colombia because I don't want to be burdened by all of those administrative hurdles that I have now in the EU. So, I don't know, but does the EC even aware of these sort of like unintended consequences that they could send ripples through the entire standardized world when it comes to patented technologies? And I think going back to points we've all made, I think that's really key for this critical and emerging technology realm. Patents are sort of the lifeblood of the ability to bring companies to the table and offer that technology to a standards organization. So we see that proposal, right? I already mentioned the US's endeavors in policy making in the standards realm and sort of our recognition that maybe it's best just to take our hands off the scale so that no one can point a finger and say, well, they meant this, or no, they actually meant that. And so just getting out of that, I think, was a smart play for us here in the US, just to leave it to the Article 3 courts, leave it to our...
Really good point.
Yeah. I'll leave it there.
I didn't mean to interrupt. I just wanted to.
Oh, okay. Yeah. So no, just to wrap it up though, because I don't want to usurp the floor here, but I think all those different things that could happen, right? Whenever there's a new idea in the policymaking realm that would affect standards, really needs to be well thought through. Really needs to be socialized with all the industries, like the EC member states or the European Union member states, I should say. To make sure that they're on board, because it's going to have real effect. And the fate is, I think, in some sense uncertain, because there's a steep hill to climb there. But as we look to sort of that coalescing, maybe there's other things we can do, right? Maybe we can figure out sort of an international tribunal, right? I've seen that idea that academics have brought to sort of say, rather than having these one-off global trotting litigations, maybe you just have one centralized dispute resolution body. But that's also a very steep hill to climb. But we need to keep thinking about these and figure out what makes the most sense so that the licensing side of standards is not fraught and that people can get returns on their investments. So that'd be my contribution.
So I think, just up-leveling it a little bit, I think what you're trying to say is that when we think about regulation of intellectual property that is related to standards,
yes,
we could be really selective and specific. And this idea of Europeans now basically marching with pretty aggressively with this idea of this SEP regulation, which the US has backed away from in the last year. We basically abandoned it. That's problematic because it has these massive consequences on whether or not the European companies will continue to invest in these standards and lead in these technologies. So I think that's a really important point. Peyton, over to you.
No, I think he really summed it up well. And then also Chris had mentioned that they're working on documents to try to explain to people about standards and standard setting organizations. A lot of these critical technology companies are startups. I mean, obviously you have the big players as well, but a lot of them are spun out of universities, and they are not the most well versed in what's their next steps, or maybe they even know that they're supposed to be working on the standard setting, but not know that they should probably file a provisional application before disclosing that to their competitors. And so having information about where they need to go and what they need to do locally and abroad, I think are great steps for smaller companies that don't know what to do, because similarly, as we've mentioned throughout this panel, the more voices, more innovation that's occurring, the better the standards will be. And having resources there is an easy way to help that globalization.
Thank you. Vishal, John, any last words on this?
No, I think Peyton's point is very well made. That's always been a challenge. I mean, all across, even for the last 20 years when the telecom technologies were happening, which is, how do the startups kind of jockey for the innovations that they've made, and it becomes even more complex in these now critical technologies, which have sort of implications in multiple areas and multiple verticals. So that education for the startups and the people coming into it as to exactly how do they hold on to their innovations, and how do they patent them or protect them is going to be quite critical. I definitely agree with that.
John.
Yeah, and in my view, it's really about making sure we can kind of maintain the investment required, right? Going back to some of the earlier conversations on that global reality of the types of investments required to successfully compete at the top tier as you're driving this technology innovation forward. So in my view, it's incredibly important that we look broadly at any of these policy proposals because of these consequences that it can undermine the ability to invest, recognizing that investment's already very complicated in terms of the people, the dollars, the timeline, the broader approach to that.
Thank you. Yeah, I mean, this is what I worry about also, that, policy needs to stay above the fray of commercial interests. And it's really important that we maintain a system of these global standards, because we talked about all these benefits. We allow investment to flow. And the truth, it's just reality that in market-driven economies where state-driven agendas and subsidies are not funding the R&D, it's the markets that are funding the R&D. We need the IP regime to be able to have some sense of a return on investment on investment in standards. So with that, I would like to open the floor for questions from the audience for a few minutes when we have a chance. See if we have questions either from the virtual participants or those in the room.
Yeah, I'll monitor the virtual ones, but you can please come forward if you have a question. Because I have one, maybe I start. Going back to one of my statistics on the 1,500 licensees, for cellular, we saw that more than 50% of these are Chinese. And actually some of that data is taken from the publicly available licensee list of Qualcomm. So that's probably a question for you, John. With that in mind, you have a lot of revenue in that country. How does that, in those situations, may also conflict with political interest and security? Because you have a business to run, you have shareholders to satisfy. How does that conflict sometimes with maybe a U.S. government view on political, geographical, challenges?
Yeah, I think that's where the simple answer is that for companies in the access to the global market is incredibly important. And I think that's the part that the types of players who are selling product, making sure that the world isn't just dominated by a few small vertical players. I think the power of innovation and standards essential IP is also that it enables participants to enter that market, based on adhering to a standard. And I think there's that perspective then that it's not really the role of the government to predict which companies are going to be successful at which point in time, and therefore to start trimming, hey, this company is a good one, this one's not a good one. The reality is that when we look at the kind of global ecosystem of technology innovation and players, it's a continuous changing mix. And whether it's M&A examples, if you look at any evolving field of technology and you go back to the core roots of where things were 40 years ago, and 40 years is ancient history in technology, versus 10 years ago. So what's really important for companies like Qualcomm is that we're able to sell our products globally, and at the same time that we're able to innovate and be in a position where we continue to invest in that innovation. And that's what enables us to create these complex systems that kind of bring together many types of innovation.
Thank you. There's a question from Gordon Gilderman.
Thanks. Gordon Gilderman from... It's good? Gordon Gilderman from the National Institute of Standards and Technology. So I'm just going to draw on kind of two themes. One from the first conversation today about AI, and another one just recently about the advent of digital and high-definition television. So in that evolution of technology from CRT-based technology for watching TV at home to high-definition television, most people didn't see a potential for societal impacts. You got a better TV out of the deal. So in AI, there's a general kind of concern that AI is going to change our societies broadly. How does that, in your opinion, affect what's going on in standards today?
Did you want to direct that to any one of us in particular? Or?
Whoever wants to take the mic on that one.
I mean, I guess one way to look at it is we're still like this profound change from large language models, and what does that mean from natural language processing to new types of transformer networks versus recursive neural networks, and so there's fields that are evolving quickly in academia, and they're evolving quickly in technology application. And what's interesting is some people were surprised by the recent, oh my gosh, I can do this sort of large language model processing. Others are like, yeah, that's not too surprising given the ongoing research in such a disruptive field. And so in my view, we're at that stage where, hey, AI is obviously going to be a very interesting tool that can enable many people to do their jobs more effectively. But at the same time, as you say, there's a societal effect that maybe it's going to change which type of jobs exist 5 years from now or 3 years from now or 20 years from now. And I think it's very hard at this early stage to start making predictions about what the transformation can be, and even which transformation is more nefarious versus which one is like, I can do this more effectively. If I'm a student, just as back in the day, I'm always surprised when my teenagers, they don't really have textbooks. When I walk into the room, I'm not really tripping over textbooks. I'm tripping over computers and cables and devices. The reality of how they're consuming information is very different than back in my day as a student, where you would just be able to kind of, this book contains the knowledge I wish to attain in the next 4 months. And so this recognition now that they have they're looking at Khan Academy, they're looking at Google, they're looking at Wikipedia, they're learning this, they're learning that. And so what's interesting at this stage of AI then, and how it ends up affecting the field of law, the field of medicine, the field of engineering, and what does that mean then for standardization? I think it's a time to proceed carefully, and at the same time, it's also a time for rapid innovation and to keep an open mind. And so hence we have a study item in Release 18 on how AI can improve things. How can it make it so the battery life of a phone is better, that the network has a smaller carbon footprint because it can actually predict when handoffs should occur versus relying on signals that are always a little bit too late to say, oh my gosh, you don't have any signal, let's hand off. And so there's examples where AI is just inherently going to improve efficiency, and then we can apply it in different ways. And so I think, in my view, we're still at the very early days of AI and what should be standardized and what should not be standardized. And so it's important to keep a very open mind as to these potential applications.
And I agree with everything John said, but just to add on, I think for me, AI is sort of a pet peeve of mine, right? Because we need to speak with some specificity about what exactly we're doing, right? And so to John's point of, if we're going to have arguably machine learning applications in any specific technological domain, maybe you need standards that are, discrete for that domain versus having just, and I think there is some value in having, broad overarching, like the NIST risk management framework for AI, like that has its value, of course, but also to, really standardize any one specific topic, right? You're gonna have to look at specifically what are you talking about, right? You're not talking about some amorphous AI, you're talking about, the application of a transformer network to some translation domain, and what is the standard for that, right? So I think that's really important to sort of drill down and make sure that we're talking and addressing specific things rather than just trying to have these cookie cutter, large swath applications of whatever AI would mean to be in that context. But I agree with John said.
And one last point about standardization is that I think, which came up in Kayvon's talk as well, is that in the AI case, and this had happened in 5G, where use cases were looked upon and standardized. So you might have the same thing with AI, not the core technology, because that's been known for a while, but the use cases and the applications, which is where the patenting and the standardization may happen. But even that could be a ways off, because as John said, it's early days. Early days of the reapplication of AI is really what I should say.
Great. We have another question here, Harry Benz.
Yeah, so as I've been listening to the discussion, it's kind of dawning on me that we really need to think of AI impact on society as contextual. So in certain contexts, it will be disruptive. in other contexts, it's more evolutionary. So for example, when we're looking at communication standards such as 5G or Wi-Fi 6, et cetera, we already have lots of innovation in the area of multivariate optimization. And AI is simply an improvement on multivariate optimization. So we already know how to do beam management. We already know how to do CSI feedback. We have lots of algorithms and work in that area. AI is simply making that better. So it's more of an evolutionary approach. But the concern that I have based on what I'm hearing is that the way AI, well, historically, standards, there was a big standards push to have open standards where anyone could pick up a copy of the standard and pick up a copy of standard essential patents, put the two together and build a working system. But it seems as though the trend now is towards only disclosing AI as a black box that's being applied in a particular context, right? And so patents around the use of AI in a particular use case are what's going forward, as opposed to giving the public detailed understanding for how to actually build the AI model that's going to be used in these different contexts. And so when it comes to standards like communication standards, do we really want to give up knowledge for how the signaling works to become a black box where the public really doesn't understand how the signaling works anymore? And only a handful of proprietary implementations can actually build a working network. Or should we be thinking from a policy standpoint for how to keep that open, at least on the signaling point, so that, for example, if the US decides we don't like a particular foreign company, producing products that are sold in our country, there will be alternatives because we understand how to build the network, or we can, home grow a company that can build the network, including down to the signaling part, because it's not proprietary, even though it's part of the standard. So I wanted some thoughts on what kinds of policy ideas you had around how to keep the implementation of communication standards open enough to allow for adequate competition.
So I can maybe start us off, and then you guys can help me out. But I think so. That's one drum that I beat often is the benefit of the patent disclosure when we think about AI systems, because there is some black box component in the sense that you don't know necessarily how the back propagation algorithm is working to update weights and within the hidden layers of a neural network. Let's say, that's true, but in order to get a patent, you'd have to disclose that architecture. You'd have to enable it so that those coming after can actually make and use it. And so we may not know specifically why a decision was made within the machine learning algorithm itself. We can still provide it to others so that they're fostering that transparency in the sense that I can go look at it. I can build out a particular network architecture. I can input enough training data into it so that at a certain stage I can reach some claimed efficiency of that network for what it's doing and operating at. And so by doing that, I think that patent disclosure actually still serves that value. There is that little element of mystery, if we want to call it that, as to why the decisions are made within the algorithm. But I think within time and within innovation, we see engineers already working towards that to sort of figure out that missing piece of explainability. And maybe that means that we're going to have different models in the future. We likely will, I think, to deploy and to mitigate that concern. But that's sort of the drum that I beat, though, is that there is value in patenting around AI versus keeping it a trade secret where it's just kept as proprietary information, where nobody really has the benefit of that disclosure. So I'll pause there and see what my colleagues think.
I'm also a patent attorney, so I have similar views that the disclosure should, you're risking a later IPR, right? If it's not enough for someone to understand what's happening, right? Someone in the art. And maybe that's what will end up happening, right? Someone will have a patent somewhere and it's not enough. And then it'll signal an IPR, which will signal a change later on for every other person drafting a patent to include more. So it might be something that later down the line, it just occurs based on litigation or something similar to that. I'm thinking of AI patents that I've read. I mean, yes, they're somewhat black box, but overall, most of these things are working in similar ways that someone who is, an AI scientist could generally figure out what's going on. But it is an interesting point of how much disclosure is enough for a standard, and how much is that going to change if like you got a patent somewhere else and they don't have similar 101 concerns and ways they draft their applications. So it might be a wait and see thing, which is never very comforting. But
we could have a whole panel on this topic.
Yes.
Listen, Tim, I look out of time, so we can take rest of the questions offline so that the show continues on time. But I virtually want to thank everybody for being there, for your participation, and I'm sorry I couldn't be with you in person today, but it was a real pleasure to join on screen. Thank you all.
Thank you, Kirti.
Thanks,
and
Kirti.
to the panel.